In question letter E, we're looking at how many quarters were in the fountain a week ago. And in the previous video, I mentioned that you could think about the table and think about what would happen if you went backwards in the table. If you want to think about this backwards approach, here's something you can do with the table to think about it visually. You could extend the table, and you'll notice I'm using a bit of extra scratch paper to kind of cover up here, and to go a little bit into the past. If you think about the top row of the table as a number line, we'd have 4, 3, 2, 1, 0. And if you think about numbers, logically the number before 0 would have been -1. So if I think about yesterday, and I'll just label that so you can keep track of the days of the week here. If -1 is like yesterday's amount of quarters, think about the pattern. We were doubling. So if I'm going backwards, I can assume that there were half as many quarters in the fountain the day before. So yesterday there must have been only 400, because 200. Because if half of 400 is 200, or if you think about it backwards, doubling 200 would give you 400, then the pattern stays true. So let's think about this. A week ago means that I have to keep going into the past. Yesterday, there were 200. If I go the day before that, there must have been 100, because there would be half as many. Or 100 doubled would be back to 200 again. So that would be 2 days ago, or the day before yesterday. So 3 days ago, there would be half as many. And 4 days ago would be half as many. And I could continue the pattern going backwards as far back as I want. Now things are going to get a little bit weird, because if you take half of 25, you're going to have a decimal. That's 12.5, and you're not really going to have 12.5 quarters in a fountain. That doesn't really make sense. So you can just say 12, for example. But you will start to get decimals if you go backwards, and you'll have to keep going backwards. Because if you think about a week ago, that was 7 days ago. And since the table is measuring in days, you'll need to think about how far back to go and when to stop, so that where you stop represents 7 days. So I stopped at day -4. You'll need to keep going backwards until day -7. If you don't think you want to do that, remember, you can use the equation instead. That's another option for using the equation instead of the table. And some people find the table kind of tedious, so the equation is better for them. If you think about your equation, remember you had T of n equals 400 times 2 to the power of something? Well, that power is the number of days that we're looking for. And since we were looking for 7 days ago, that would be the number that I want to plug in. But here's the thing. Remember how when we're thinking about the table, today is day 0 and yesterday was day -1? If I'm talking about the past, I have to use a negative day number to show that it's talking about past days. Positive day numbers tell me about days in the future. So negative day numbers tell me about days in the past. And I'll need to use -7 as my exponent to show that this is a past day, not a future day. If I plugged in +7, that's like 7 days from now. That's like a week into the future. And that's not what this question wants. Now, just for formality, I'll put the -7 on the left-hand side, but it's not really the left-hand side that matters. That's not important. The important part is the right-hand side. I can plug in -7, and I can use my calculator to do that job. Now, if you don't have a fancy graphing calculator, that's okay. Most calculators still have an exponent button. Even your phone calculator does. So you can do this lots of different ways. In fact, I'll do this example with a standard style calculator so you can see that you don't need anything fancy to do this. I personally usually do the exponent first, because that's what PEMDAS does. Exponent first, then multiply. So 2 to the power of -7. I like to put negative things in parentheses just to be safe. It's going to give me a crazy looking number, but don't worry, because we're not done. Then I take that number times 400, and that gives me my number that I'm looking for, 3.125. Now, 0.125 doesn't make sense, because remember, this is a number of quarters. You can't have a partial quarter. A quarter is a physical object. So we would say approximately 3 quarters. There are approximately 3 quarters in the fountain. Now, if you want to say approximately, but you don't want to write the word, a little squiggle like that is usually a way of saying approximately. So roughly 3/4, if you will. Now, in part 2, it wants us to use actual rules to show how this answer makes sense. And this is actually something that we'll review a bit of algebra that we did way back when we were still in in-person classes that have to do with negative exponents. If I didn't have a calculator that could do an exponent for me, this is actually a problem that we should be able to do. Remember that idea that sometimes when you have negative exponents, we can flip them, and flipping a negative exponent kind of takes care of the fact that the negative is confusing and it makes it a little bit easier? Well, what I could do is write this thing as a fraction, because technically even the original problem is a fraction, it's just over 1. And I could tell myself, hey, 2 to the negative 7, that has a negative exponent. Remember, the rule of that is that we can flip it to the opposite part of the fraction, flip it to the bottom, and that makes the 7 positive. When I flip an exponent, it makes it positive. Now, the 400 technically has a power of just 1. We didn't even think about the power there because we don't really need it. And that's not a negative power, so I would just leave the 400 on the top. Now, if I look at that, that's actually a problem that, again, we can do with algebra. 400 on the top is still just 400. 2 to the power of 7, again in my calculator, any calculator will do this, is 128. And if I take 400 divided by 128, I end up with, not coincidentally, the same exact answer that I got before, 3.125, which is approximately 3. And that, of course, is the same answer that I got before. So the idea is that you could use lots of different ways to get this number. You could use a regular calculator, you could use a table, or you could use negative exponents and do it with algebra. Lots of options, all of them will work. If you feel as though this makes sense, and if you feel like now you have some tools that you can use, try question number 4 and question number 5. Again, if you can do these without the videos, great. And if you need the videos, no big deal. But this will at least give you some examples that you can use as a forward step so that you can try some of the questions a bit more independently.